Okay, now we're on example 5 from Text and Text 4 1.2. So we have a linear function here, and we want to drop in a negative 2. So let's drop in, let's write it again anyway, just to set ourselves up right. So we put in what's called a dummy variable of 3. We'll substitute 3. 6 take 4 is 2. Substitute negative 2. And of course, just substituting t means you just write f of t equals 2t take 4. There's your dummy variable. Now, what value of t makes ft equal to itself? So if it's equal to itself, 2t minus 4 equals t. Okay, so t equals 4, solving that. So let's see, a rectangle has one side 4 centimeters longer than the other. Okay, that's how we can model it. Find an expression for the area. Area of x. An expression for the perimeter. Okay, so the half perimeter is 2x plus 4. The perimeter is double that, 4x plus 8. And we want to write it in function form, so we're writing it like this. So we're going to do long division with dividing the ends. With a quad over linear, we'll divide the ends. So what we have is, we have 3x minus 1, and we have 2x minus 2, no, plus 2. Okay, the reason for that is minus 1 into minus 2 is 2, and 3x into 6x squared is 3x. So we have a 3x plus 1 here. Now that's the difference of two squares when we multiply them together. Expression for the width done. Width in x is 3x plus 1. Expression for the perimeter, of course they were just, I don't know why they didn't ask us the area, but we'll do the area as well. But we'll start off with the perimeter. The half perimeter is 6x. The plus and minus 1 cancel, and the perimeter is 12x. And just to force ourselves to use function notation, I'm going to write it like that. And just for laugh, we would say, even though they didn't ask, that the area is difference of two squares, so 9x squared minus 1. So before we look over to the right, let's look at the writing here. So the important thing here is that it's an open rectangular box. So the top piece, if it's open, an open box has the top piece missing. That's the assumption. So the volume isn't affected by the fact that it's open. Surface area is affected. And then we'll get some specific values. So let's work underneath this now. So the volume in x is x by x plus 1. Technically speaking, you can stop right there. Okay. However, just in case they want us to expand it, let's look at the two cross products in x. And you get 2x and 3x is 5x. So here what we have is and we still have this. So it's a trinomial with no constant term. And we want S of x, which will be the bottom face which is, by the way, this and this multiplied by each other. Plus this perimeter, which is 3x plus 3, doubled, times x plus 1. Which is actually 6 times the square of x plus 1, which is 6x squared plus 12x plus 6. And then we've just a few values to get. We need to know what they are at 5. And we want to know what this is at 5. So that's all I want. That's the extra bit. Okay, we'll do one more here. Post a video. Okay, to put in 0 is to take the constant. To put in 1 is to add the coefficients. It's important you know that. What are we looking at here? 8. Okay, to put in -2, we'll kind of just do it out properly. Careful with double negatives. Okay, this is negative. This is negative. Positive. Negative. Okay, that partially goes with that to give us 8, and we have 18. Six. 25 take 15 is 10. 16. Quarter plus 3 over 2. Let's call it 6 over 4 because we're in quarters now. Okay, let's call it 24 over 4. 31 over 4. There's the length. It's x minus y. There's the width. Well, I don't need to be three-dimensional on this. It's 2x plus 3y. Okay, the area. Now, these are similar binomials. So they will take very well to the rainbow type of expansion because there will be grouping because of the similarity. So in other words, that and that will be similar. The ends won't. So we have a yx and we have a minus 2yx. So now all together we have 2x squared minus yx because of the grouping here, and then a minus y squared. So that's your area. Now that's very lazy, but it's good maths, we can do that. Perimeter. Well, we go ahead and add these and we get 3x, and add them and you get 2y, and that's the half perimeter, so we'll double it up. We'll say the perimeter in x and y, if you want to do that you can, is 6x plus 4y. Done. Again, to keep going with open, they just seem to be obsessed with open. The width of an open rectangle is 5. No. The width is 5 shorter than its length. And the height of the box is twice the length. Okay, so length is going to be x, 5 shorter, and 2x upwards. I just want to check that I've used as they've said here. I'm only getting to this now by letting, and maybe I should have read, maybe a little guideline for us is to keep, try to get all that skimmed first before we start analyzing. But I'm okay, because what I've done is I've said this is x and this is 2x. Length of the box, 5 shorter than the length, so that's good. Expression for the volume. Well, we're going to have 2x squared times x take 5. 2x to the 3 minus 10x squared is the volume of x. The volume in terms of x. An expression for the total surface area. So I'm going to have one of these. Let me give a bit of a run at this. One of these. We're going to go with this perimeter multiplied by 2x. So let's get this perimeter first. The half perimeter is 2x take 5. The full perimeter will be doubling it, and it'll be going with 2x, because you see all of that side could have been stretched out and then gone up by 2x. Again, a big long, with 4 sections. That's what this is here. Okay, so ready to tidy that up? Are we? So 4x on this is 8x squared. Now we have 4x on this, which is minus 20x. We still have these fellas here. So altogether we have 9x squared minus 25x. N squared minus 3n all over 2 is a nice way to write that. So for example here, how many diagonals have we? 1, 2. There's 4 sides there. I just want to check it here. Would that be yeah, so now we have 2, minus 3n squared. Oh no, this should be 16. 8 take away 3. So this is perfectly normal part of problem solving. It's not something I need to hide in the video. We're trying to make sense. Does this make sense? The number of diagonals in an n-sided polygon. Now, do you agree that this has 4 sides? Yeah. Do you agree that we can common denominator of 2 can be written as common? So we have 4 squared minus 3 fourths. There we go. All over 2. 16 take 12 is 4 over 2 equals 2. And that's definitely true what we see here. We can count them here. 1, 2. We go over here. 3, 4. I think we've everything done now. Is there any corner? No. 5. That one is done. 5. Here you have 2 out of it, 2 out of it, 2 out of it. Make sure there's 2 out of everywhere. So we end up with 5. Well, 5 squared minus 3 5s all over 2 is indeed 5. Okay, so we're kind of convinced ourselves that it's true, but now we'll answer the more abstract academic mathsy problem. Explain what is meant by the number of diagonals. So D4 means the number of diagonals in a square in a polygon. It doesn't really say it's square because it's in a quadrilateral. Okay, the number of diagonals in a quadrilateral. The number of diagonals in a pentagon, and we've done those two already, so we're on to this one. So we're on to 6 squared minus 3 6s over 2. 6, 18 equals 9. Explain why D3 equals 0, because a triangle doesn't have any diagonals. Okay, you're not allowed to use the side itself. There's no opposite corner to this. There's only an opposite side. So we're putting a squared in instead of x. Get a squared plus 5. Oh, so you. Apologies. Let's do it this way. F of a squared minus 3f of a plus 2. Let's lay ourselves out this way. Okay, so you get a squared plus 5. Take 3. You see a going in here. Here at least would be a plus 5. So take away 3 of them. Well, minus 3 a plus 5. Just a little bit of side gig there. Minus 3a, I'll put it here. Minus 15 and 2. We get a squared minus 3a minus 8. So just go into this with whatever dummy variable they're asking for. Same again. Say f of t squared will be something squared minus 3 times something plus 6. That's the important thing. Now drop in your t squared. And you get t to the 4 minus 3t squared plus 6. And we've one to go. We're dropping in t minus 2. So f of t minus 2 equals something squared. Take 3 of them plus 6. T minus 2, t minus 2. So that's t squared minus 4t plus 4. This is minus 3t plus 6 plus 6. You're scooting along there looking for bits and pieces, and you're getting your t squared minus 7t, 12 and 4 is 60. Okay, just rub that out. T squared minus 7t plus 60. Need that space now. T squared minus whatever I just said. 7t plus 16. Yeah, we know that formula anyway. It's in the tables. So the volume of a cone depends on the radius and the height, like this. And radius is 14. Now I'm going to do a few tricks here. 21 and 14 have a common 7. So check this out. We're going to go half of pi. Now I'm going to go 3 squared, 7 squared, that's 21 squared. Okay, and 14 is 2 times 7. Okay, they cancel. We know what 7 cubed is. 343. Now you could use a calculator now. We've 343 for 7 cubed. And we've 9. We've pi. Okay. Then you can take out the calculator. You can just be kind of a martyr. so slow on this. No, it's probably in terms of pi, so all we're doing is multiplying 343 by 9. Now, some of you will have that done in your head, no bother. Okay, look, I look at it there, 3087. Now, I should have done this. 343 by 9. You see if the carry, and I don't like carrying. Yeah. What? Yeah, 1 second. And then 27. Yeah. Okay, and then that's in terms of pi. It's twice the height. I'll come back to that later.